Influence of precipitation on mountain erosion. We'll build an intuition for why windward slopes are wet and erode fast, while leeward slopes are dry and erode slowly, and then connect these ideas to real orogens like the Himalayas and the Andes. First, the orographic effect. Moist air flows toward a mountain. As it rises on the windward side, it cools and rains. The windward slope becomes wet with strong rivers and landslides, carving deep valleys. Descending on the leeward side, the air warms and dries, creating a rain shadow and weaker erosion. This wet to dry gradient translates into erosional asymmetry across the range. Now, the monsoon-dominated Himalaya. Most rain falls on the southern front. Rainfall drops steeply toward the Tibetan Plateau. Let's visualize a south to north precipitation gradient and its erosion response. Where rain exceeds about 2 to 3 meters per year, denudation is measured in millimeters per year. In the rain shadow, it can be a few tenths of a millimeter per year. This leads to youngest cooling ages and rapid exhumation along the southern front. The Andes span multiple climate zones. In the north, wet climates produce narrow, steep ranges with deep gorges. In the central Andes, extreme aridity curbs erosion, enabling a broad high plateau. In the south-central Andes, westerly storms soak the Chilean flank with a dry rain shadow to the east. Range width, hypsometry, and even crustal thickening patterns correlate with climatic erosivity. Arid or semi-arid ranges often preserve topography because runoff is scarce. Sediment can pile up as coalescing alluvial fans, or bajadas buttressing range fronts. Erosion rates can be as low as hundredths of a millimeter per year in hyper-arid belts like the Atacama. Quantitatively, erosion often rises with precipitation at first, then saturates or even declines when dense vegetation protects hill slopes. Let's sketch a conceptual curve of erosion rate versus mean annual precipitation. Note 3 regimes: low rain, low erosion, moderate rain, rising erosion, very wet, diminishing returns. We'll place example points: Olympic Mountains, arid East Sierra, and Southern Alps. Let's summarize. 1. Orographic lifting creates wet windward and dry leeward slopes, producing erosional asymmetry. 2. Monsoonal belts like the Himalaya show focused south flank erosion and rapid exhumation. 3. Along strike climate contrasts in the Andes help explain range width and plateau growth. 4. Arid climates preserve topography and can buttress range fronts with sediment aprons. 5. Erosion generally rises with rainfall, but extreme wetness with dense vegetation can limit further increase.